Hello, wonderful people created in the image of God Almighty. Welcome to my channel. This is Donald C. I'm an author of A Hidden Mathematical Genius Within Revealed. We continue on gamma functions. I show that the integral from 0 to 1 of x to the power m, natural log of x to the power n with respect to x is equal to minus 1 to the power n n factorial over m plus 1 to the power n plus 1, where n is a positive integer and m is greater than minus 1. Okay, so what we do here, we need to have exponent in our integral. So what you do, where we have a natural log of x, we're supposed to relate this to exponent. But what we can do, we can just let this to be just a variable, because we know that the natural log is the reciprocal of an exponent. So if you introduce exponents to both sides of the equation, then the natural log will go out. Okay, so we'll say solution. We let natural log of x to be equal to just a single variable. So in this case, let's say t. Now in our definition, the exponent is supposed to have a minus. So let's put a minus there. Okay. Then next step, to get rid of the natural log, we are going to introduce the exponent. When we introduce the exponent this side, we remain with x. So it will be exponent here will be x is equal to exponent there, it will be exponent of minus t. So where there is x, we are going to put exponent of minus t. Okay, so we also find the value for dx. So dx is equal to the derivative of exponent of minus t will give us minus exponent of minus t. Okay, so since this is in terms of t, so multiply with dt. Okay, so the moment you change variables, we should also change the limits. Okay, so limits, our initial limits were t, that is from 0 to 1. This is changing to x. Okay, our initial limits were x, that is x from 0 to 1. Now we are changing to t. Okay, so first thing, where there is x, we are going to put a 0. So if you put a 0 there, the natural log for 0, log of a 0 is always infinity. So we are going to have infinity. Okay, when you put 1, where we have x, the natural log for 1 will be 0. Log of 1 is always a 0. So there we have 0. So our limits have changed from 0 to 1 to infinity to 0. Okay, so we have integral from infinity to 0 of, where there is x, we put exponent of minus t. So we have exponent of minus t. This is to the power m. Then where there is a natural log of x, you put minus t. So you have minus t there to the power n. Then where there is dx, it's minus e exponent of minus t. Okay, so minus exponent of minus t, then dt. Okay, then what you should remember is that when you multiply the integral with a minus, the limits will change. So this minus is going to change the limits here. They will swap. Okay, so we are going to have 0 from 0 to infinity. Okay, so we have integral from 0 to infinity of, here we have exponent of minus t, and here we have exponent of minus t. So we can say that these have same bases, so we can just multiply the powers. So the power here is m, the power here we consider it to be 1. So we are going to have m plus 1, it will be m plus 1. So we are going to have e to the minus t, then again to the power m plus 1. Okay, then here we have minus t to the power n dt. Okay, again here what we can do is we can make this t to be positive. How can we make it to be positive? Okay, so we can divide out a minus 1. So when we divide out a minus 1 here, it will carry even the power of n. Okay, write it to the front here. So we are going to have minus 1 to the power n. So we are going to have integral from 0 to infinity of exponent of minus t in brackets m plus 1, then t to the power n dt. Okay, again we know that for this integral to make sense, as in terms of the gamma function, we know that the exponent, the power of the exponent here should be just a single variable. So again, we are going to let this whole thing on top here, t m plus 1, we'll let it to just a single variable. Okay, so we say let t m plus 1 equal to, let's use u, equal to u. Okay, then we can make t the subject of the formula. So how do you make t subject to the formula? You just divide to both sides of the equation m plus 1. So you get t is equal to u over m plus 1. Okay, so having t, making t subject to the formula, we can now find dt. Okay, so you say dt is equal to, you differentiate now this with respect to u. So m plus 1 is constant, so we have 1 over m plus 1. The derivative of u with respect to u, it will be 1, then multiplied by du. So this is du. So dt is equal to 1 over m plus 1 du. Okay, then after that, you should also look at the limits, because whenever you substitute, even the limits must change. Okay, so limits. So we are coming from t. So t, the limits are from 0 to infinity. We are changing this to u. Okay, so where there is t, just put a 0. So if you put a 0 here, this whole thing will be 0. Okay, if you put infinity where there is t, infinity multiplied by any number, it will be infinity. So the limits will remain unchanged. Okay, so where there is t, we are putting u over m plus 1. Okay, so next we have, okay, it's the integral from 0 to infinity of exponent of, so where there is minus t, where there is t in brackets m plus 1, it's u. So we have exponent of minus u. Okay, then where there is t, it's u over m plus 1. This is to the power n. Then where there is dt, it's 1 over m plus 1 du. Okay. Then our next step here, what we can do is we can divide out the constants. Okay, so here we have a minus 1 to the power n. We can divide out the constants. So here we can divide out 1 over m plus 1. And don't forget that 1 over m plus 1 will have the power of n. And here we have 1 over m plus 1. So these two will multiply. So 1 over m plus 1 to the power n multiplied by 1 over m plus 1. Since these are same bases, you just add the powers. So n plus 1, you get n plus 1. Okay, so you take it outside the integral. So we are going to have minus 1 to the power n multiplied by, so we have 1 over m plus 1. This is to the power n plus 1. Okay, so we have integral from 0 to infinity. Here we remain with exponent of minus u. Then here we have u to the power n. Okay, then du. Okay, then next we multiply these two, so you get minus 1 to the power n, and this would be over m plus 1 to the power n plus 1. This is integral from 0 to infinity of e, that is exponent to the minus u, then u to the power n du. Okay, now this integral is the definition for gamma function. This is the definition. Gamma of z is equal to integral from 0 to infinity of exponent of minus t, then t to the power z minus 1 dt. Now this one is just in terms of u. So we'll think of the u as a t. Okay, now here we have the power of n. So what you do is you just equate this n to z minus 1, since here there is z minus 1. Okay, so we say z minus 1 is equal to n. Then we make z the subject of the formula. So to get rid of the minus 1, you just add a 1. So if you add 1, it will cancel out a minus 1. And you also add 1 this side. So we have z is equal to n plus 1. Okay, so you know that this integral is just a gamma of z, and z is n plus 1. So we are going to have n minus 1 to the power n over m plus 1 to the power n plus 1 multiplied by gamma of n plus 1. And I believe you remember that gamma of n plus 1 is just n factorial. So when you are coming from gamma function and you want to change to factorial, you just subtract a 1 in the gamma function. So when you subtract 1 from n plus 1, you get n. So this will be minus 1 to the power n. So gamma of n plus 1 is n factorial, and over m plus 1 to the power n plus 1. This is what we have, hence shown.